Hello all, I am Deepali Adhyapak. Today I am going to discuss Huffman coding. The contents that I am going to cover are Introduction to the source coding and Huffman coding. The output of any physical source in its original form contains lot of redundant bits, and transmission of such data results in wastage of time, bandwidth and power. Hence source coding is done. Main objective of source coding is to remove redundancy and to make data more compact. There is a limit on data compaction to avoid the loss of any information, which is given by Shannon's source coding theorem. There are different source coding techniques such as Huffman coding, Shannon-Fano coding, Lempel-Ziv coding and run-length coding. Huffman coding and Shannon-Fano coding are based on the statistics. Today we are going to see the Huffman coding. Huffman coding is a suboptimal compact coding scheme which is used for data compression. It is a basically variable length coding technique in which most frequently occurring messages get smaller codes and least frequent occurring messages get larger codes. In this coding scheme, the probabilities of occurrence of symbol is given. We will take one example in order to understand how the Huffman coding takes place. Here a discrete memoryless source is given which emits the source symbols from S0 to S4, and their corresponding probabilities are given such as 0.4, 0.2, 0.2, 0.1 and 0.1. Now in the first step of the Huffman coding, we have to arrange all the symbols in the descending order of the probabilities. So here we have arranged all the symbols in the descending order of the probabilities. Then we have to do the reduction in the further stages. While doing the reduction, the lowest two probabilities are combined together. Here when we will combine the lowest two probabilities, it becomes 0.1 plus 0.1 which is equals to 0.2. Again in the next stage of reduction, we have to maintain the descending order of the probabilities. 0.1 plus 0.2 is equal 0.1 plus 0.1 is equals to 0.2. This probability is same as that of S1 and S2. Now here in order to maintain the descending order, we need to place this above S1 or below S2. So when if we will place this 0.2 above S1, then that is called as a as high as possible method. And if we are going to place it below S2, then that method is as low as possible. Here we are going to follow as high as possible. So this point here we are maintaining a descending order of probabilities. So 0.4 is the highest probability. So in the next stage 0.4 will be at the first position. This 0.2, which is the sum of 0.1 plus 0.2, 0.1. So we are going to place that above S1. S1 will get shifted down, S2 will also get shifted down. Now again the lowest two probabilities are combined, which gives us 0.2 plus 0.2 which is equals to 0.4. As we are following as high as possible method, this 0.4 is placed above at the first position, and S0 will get shifted down like this. Then this 0.2 will get shifted down. Again the lowest two probabilities, that is 0.4 plus 0.2 becomes 0.6 which is the highest one. So we are going to place that at the first position, and 0.4 will get shifted down. So 0.6 plus 0.4 becomes 1. We will stop here now. Now to each branch we are going to assign a code word. So the code will be either 0, 1 or 1, 0. If we are assigning 0, 1, then to each branch we have to assign it as 0, 1 only. So here we have assigned 0, 1. To this branch also we are going to assign 0, 1. To this branch also we are going to assign 0, 1. To this branch also we are going to assign 0, 1. Now the next step is to find the code word. So in order to find the code word, we are going to trace the path of the symbols in the reverse order. So here we can see for S0 the code word, we are going to trace the path of this red line. Here 0 is assigned, here also 0 is assigned, here to this branch no code word is assigned, Here also the no code word is assigned. So the code word for S0 is equals to 0 0, this 0 and this 0. Now for S1 we are going to trace violet color path. Here you can see 1 is assigned to this. Here no code is assigned. Here 0 is assigned. Here no code is assigned. So the code word will be 1 0. Now for S2 we are going to follow green path. Here 1 is assigned. Here no code is assigned. Here 1 is assigned. Here no code is assigned. So our code word will be 1 1. Now for S3 orange color path we are going to trace 0, here 1, here 0. So 0 1 0 will be the code word. Now for S4 the black color path we are going to trace. Here 0 is assigned, here 1 is assigned, then here no code is assigned, here 1 is assigned. So our code word will be 0 1 1. Now next step is to calculate the efficiency, because we are doing the Huffman coding in order to improve the efficiency. Now how to calculate the efficiency? Efficiency is equals to entropy divided by the average code word length. Now what is entropy? Entropy is nothing but the average information content per source symbol. And what is average code word length? In order to find the average code word length, we need to find the length of each code word. The length of each code word is nothing but the number of bits in a code word. So here we can see for S0, in the code word there are 2 bits. So length will be equals to 2. For S1 again 2 bits are there, so 2. For S2 2. For S3 3 bits are there, so code word length will be 3. For S4 code word length will be 3. The code word length is given as or denoted as small l. Now the next step is to calculate the efficiency. Here we need to calculate the average code word length. Average code word length is denoted by capital L bar. Now here capital L bar is equals to summation over k pk into L, where k is the number of symbols, pk is the respective probability of the symbol, lk is the length of each code word. So L bar is calculated over here, which is equals to 2.2. Then entropy is calculated. Entropy is nothing but the average information content per source symbol. It is calculated as h of s is equals to summation over k pk into log to the base 2 of 1 by pk. It is calculated, which is equals to 2.12193 bits per symbol. Then efficiency we need to calculate. Efficiency is equals to h of s divided by L bar, which is equals to 96.36%. In this way we are going to calculate the efficiency for Huffman coding. Now as we have mentioned earlier, in case of the Huffman coding, the length of each code word is variable, that is it is a variable length code word, and the efficiency of the code word is also much higher, which is nearly about 96.36%. This is all about the Huffman coding. Thank you.